All right, so we're on test 7. We already finished the gridded response for the no calculator, which we do those first, so that way we can come back and guess if we have to. But now we're looking back at good old number 1. So timing-wise, we would be kind of in the middle of our no calculator test. Remember, this entire test, you get 25 minutes. So since we just answered 5 questions that were gridded response, you should be, let's say, about 5 to 7 minutes into your test if we were taking this live. Okay, so back to number 1. Same formula sheet as they always give you. And number 1, oh, not too bad. You got a nice linear equation here. So the equation above relates the number of minutes, yep, X, that Maria spends running each day, and the number of minutes Y that she spends biking. So adding biking plus running, what does the number 75 represent? So that was actually a really easy question if you don't get bogged down by the words. It would be the number of minutes spent running and biking each day. So C. It's question number 1 on the test, guys, so it shouldn't really be like rocket science or anything like that. Oh man, it's not going to work. You better work. Alright, so C is your correct choice there. Which of the following is equivalent to 3 times the quantity x plus 5 minus 6? You just got to distribute the 3. Just don't do anything goofy. So 3x plus 15 minus 6. Collect your like terms right there. And that gives you 3x. Sometimes I add weird, but not today. Plus 9. So your choice would be C as well. And this might be a good moment to address the old C is the most common answer thing. I know some of you have heard this before. C is not necessarily the most common answer choice, but I will say if you're just flat blindly guessing, B and C are good ones to choose. All right, number 3. So our friends who sat through the last practice test, test 5, we saw, I think, 4 different systems of equations on that test, and that's typical for an SAT test. So here's your first system of equations. Remember, your options are to graph, which you probably don't want to do, substitute, and then elimination. So this one's a great candidate for substitution because one of the variables is solved for. So I'm going to substitute that expression in for x. So we have y minus 3 over 2 plus 2y equals 6. And they want to know the ordered pair. And I noticed for my ordered pairs, all of the y values are all different. So once we find y, I'm going to be able to stop the question, which is okay. You don't have to finish the question. I'm not a big fan of fractions, so I'm just going to come through and multiply everything here by a 2. I'm going to double all the fractions. So like this first fraction, the 2's would cancel. And you get y minus 3. And then you get a plus 4y. And you get a 12. You don't have to do that, guys. I just really don't like fractions, so I like to knock them out. So collecting your like terms. Y and 4y is 5y. You're going to add the 3 over here. Ooh, it's ugly, sorry. Equals 15. So y equals 3. And I'm not going to bother to finish this question because I look at my choices. That's the only one with y equals 3. I'm feeling pretty confident about my math there. However, if I felt like I was good on time, or maybe I'd put a mark next to this question to come back and just finish the question up to make sure that x does equal 0. Actually, you know what? That's stupid, guys. Just go back up to that thing I boxed in green. If you plug in 3, do you get 0? Yeah, there, checked, done. Okay, number 4, which of the following complex number is equal to that? All right, so when they give you a question on complex number system, I have a short Fast 5 SAT video on complex number systems if you need a better refresher than this, but they will tell you that I represents the square root of -1, and the thing that I need you to remember from this expression is if you were to square both sides of this, this says I squared equals -1. That's the thing that you have to remember for algebra, is that anytime you have an I squared pop up in your math, you have to replace it with a -1. So we have an I squared in our problem, don't we? It doesn't matter when you replace the I squared with -1, just eventually. So you can distribute the negative if you'd like, and you get 5 plus 12i minus 9i squared plus 6i when you distribute all the way through. And then, of course, you're going to want to collect your like terms. But remember, this term right here, because I squared is -1, this term really says a plus 9. So when you combine the plus 9 with the 5, that gives you a constant term. The a term is a 14. And I'm going to live dangerously, and I'm just going to say the answer is D. That was a little probably too dangerous. I should have finished the question, but I didn't because I'm crazy like that. All right. Hello. We're on the, that's okay. I have to shout because I'm recording and my mic is, but it's okay. I'm not shouting at you. Where are we at here? Number 5. Now notice, guys, even with me talking, we've just dropped through quite a few questions in a very little amount of time, so I think we're good on time. We have a function, and they want me to evaluate f of -1, which means I'm supposed to I'm supposed to substitute in -1. Remember, this is a non-calculator question, so it does all have to be up in the noggin. As your math teacher, I am a little concerned about how some kids plug in numbers, quote unquote. Not that any of you would ever do this, but I have a lot of kids who do not simplify this properly. For instance, when you take -1 and you square it, that term right there is a big source of problems because kids are very, like, grab my calculator and do it on my calculator, but we can't. So what happens when you take -1 and square it? You get +1, yeah. And then -6 times -1 is +6. So you have 1 plus 6 plus 3 in your numerator. And then you have -1 minus 1, which is -2. So what do we have here? 10 over -2, which is obviously not that. It's -5. Are you checking me for mistakes? You should. All right, number 6, right below that. A company that makes wildlife videos purchases camera equipment for $32,400. The equipment depreciates at a constant rate for 12 years, which is considered to have no monetary value. So they don't call it this, but what we're looking at is a linear function. It's behaving like a line. So it starts out at 32,400. And if it depreciates, that means it subtracts a constant amount of whatever it is for 12 years. So I'm going to call that 12x. And then they're saying it depreciates all the way down to having no monetary value, which is just a really fancy way of saying equals 0. I got bad news. We can't use a calculator. So anyone see a problem coming up here with someone who can't use a calculator? Oh boy, we're going to have to divide. We got this, guys. Y'all passed 4th grade, right? If a 4th grader can do it, that means so can you. 32,400 needs to be divided by 12. Okie dokie. Long division. Who's got it? You just did polynomial long division. You have this. The first step is to divide, right? So 32. How many times does 12 go into 32? Without going over. Yeah, twice. So 2 times 12 is 24. And then to see how far off you were, you do a little subtraction problem. So what is that, 8? Oh boy, I got to pull out the big guns. 84 divided by 12, that's something special. It's 7. And that's actually an even division there. 7 times 12 is exactly 84, okay? So everything else, the zeros can just come back up. So 2,700 is what we just found to be this number. That is technically, well, it's the rate that it's depreciated each year. So if I wanted to give it a name, it's the slope. Does that make sense if it keeps going down by that much each year? But that's not the question, so be careful. The question says, how much was the camera worth 4 years after it was purchased? So if it started out at $32,400 and it depreciated $2,700 for 4 years every year, well, that looks super fun. I don't think we need to finish the question though, guys, because look at the choices. This is like, can we just do a little rounding game for a minute? Can we pretend that's 3,000? 3,000 times 4 would be like 12,000. So if I took 32,000-ish, subtracted 12,000-ish, we're at like 20,000-ish. So there's only one answer there that's 20,000-ish. So now I have full faith that y'all could have done this and got the exact answer. I know you can. But remember, time is the name of the game. So if you don't have to execute the whole question, that's going to save you time. Oh, my friend the quadratic. Okay, you have options. You can either be a master of completing the square, or you can be a master of foiling. Decide who you are. So if you're a master of foiling, you're going to crank these out and remember how to distribute a binomial who's being squared. And if you just love completing the square with the best of them, you're going to do completing the square, but you have to be careful. You got to balance it out kind of weird. So anyone have a vote for completing the square? Otherwise, I'm going to do it the other way. Okay, we'll do it both ways. It'll be fun. All right, so here, this term right there, if you were to expand the binomial x plus 3 squared, that's like x plus 3 times another x plus 3, right? So that's x squared plus 6x plus 9 plus 5. Is that going to get me here? Is that going to simplify to here? No, it's not. I mean, it's close. What's the problem, though? Yeah, that plus 5 is the problem. If this wasn't plus 5, if it was, say, I don't know, minus 5, I'd be in business. Is that an option? Yeah, right there. Boom, done. That wasn't bad. All right, my friends who love completing the square. You would have gone x squared plus 6x plus mystery number plus 4. And then because you're on the same side, like one expression, you'd have to subtract the blank. So the blank here would have been a 9. And then when you strategically group these two together, you get x plus 3 quantity squared. And then adding these together, you get a minus 5. So either way, you get B. It's just a matter of preference for most children, especially under stress. This probably would have made them feel real good just to FOIL it out. But what do you think is a super common mistake on expanding a binomial like that? Not that any of you fine folk would do this, but what do you think a lot of kids do when they're under pressure? They tell me it's x squared plus 9, and they totally forget the middle part, which is a big mistake. So be careful there. Oh, words. All right, Ken is working this summer as part of a crew on a farm. He earned $8 per hour for the first 10 hours. Because of his performance, he was given a raise of $10 per hour for the rest of the week. Ken saves 90% of his earnings. What is the least number of hours he has to work in order to save at least $270? Now, anyone really big fan of the plug and chug method on questions like multiple choice questions? Yeah, a lot of kids are. That is a fantastic method, except there's an art to plugging and chugging. Where would I start my guessing, my plugging, if I was going to do this one? Would I start at the highest number or the lowest number? In this problem, I would start at the lowest number because it says what is the least number of hours that he must work in order to make this happen. Now, keep in mind, you don't get a calculator on this question. So plugging and chugging a whole bunch is not really my favorite way to do this question. You're welcome to, though. If you pretend like, oh, be careful. It says the rest of the week. So these are his, like, quote, overtime hours or whatever you want to call it. So, like, for instance, if we thought 16 was the answer, he already worked those first 10 hours at the other part of the job. So, like, no matter what, he makes us $80. And then if he worked 16 more hours at $10 an hour, how much extra money is that now? $160, but he's only saving 90% of it, so then I'd have to do some quick math to figure out if that worked. Okay, I got a better way to do this question, I think. Maybe, I don't know. I'm gonna set up an equation. Big fan of equations. Oh, we didn't hand out the review yet. You can have it. You're okay. So $8 per hour for 10 hours. That kid's gonna make $80 no matter what, right? Then he's gonna make $10 per hour for a mystery number of hours. So I'm gonna call it plus 10x. And I want it to be once he saves 90% of it. So this is kind of tricky for kids, but remember, there's a lot of ways you can write 90%. For now, I'm just gonna write it as 0.9. I want this to come out to $270. I know it's technically at least $270, but just leave it like that for now. Okay. Remember, no calculator. What's another way to write 0.9? 9 over 10. Save the day there. Hey guys, how do you get rid of a fraction? Multiply by the reciprocal. Remember, no calculator. So these are gone. And you have 80 plus 10x equals, okay, when you're multiplying fractions, if you don't have a calculator and you're a little kid who has to do it in their head, the best way to do it is to cross-cancel. Cross-canceling that would give you a 30 times 10, so this is a 300. All right, save the day, guys. Subtract 80 from both sides. Oh, we got 220. And then divide by 10. Please tell me 22 is an answer. Okay. Now, my friends who were fans of plugging and chugging, we talked about going from the lowest one and working our way up. The good news is you wouldn't have had to plug and chug too much. The bad news is you would have had to done it twice. So I think as far as how much math did I have to do without a calculator, it was kind of potato at that moment. Like you had to do a lot of math even with the equation one. I liked that question for our SAT prep because it covered a lot of 4th grade math that maybe we need a little brush up on. Like for instance, the question ago, we had to do long division 2 questions ago. Those are things that you will be expected to do on the no calculator part of the test. You got to be able to multiply, divide, which I know everyone's like, no, why? Because if a 4th grader can do it, so should a college-bound child, right? That's their theory. Oh my gosh. That looks like a lot of writing. But the good news is, guys, it's really not that hard of a question. You're just going to match up the words with the inequality systems. This is technically what we call a linear programming system, but we don't have to really go as far as to find the profit function or anything weird like that, or the optimization function. All right, just translate really carefully with me, guys. We have, we are told somewhere in the problem what x and y represent. Figure that out first. So x is the number of junior directors and y is the number of senior directors. So keep that in mind. So Marissa needs to hire at least 10 staff members for an upcoming project. So she has to hire a combination of x plus y has to be at least 10. Now be careful, guys. X plus y. Is it less than or equal to 10 or greater than or equal to 10 if they're saying you need at least 10? It's greater than or equal to 10. I know, because they use the word least. I get why people are confused by that. But at least meaning 10 or greater. Like, why don't they just say that? Because they're trying to trick you. That's why. So that one's gone. And that one's gone. Okay. Well, 50-50 shot. Let's keep going. This is what I do now. I look at how they're different. Well, this is how they're different, guys. They're greater than or equal to simple. So let's just get one more of them right, and then we're good. She must hire at least 3 junior directors. So is this at least 3 or is this at least 3? At least 3 would be greater than or equal to 3. That guy right there. Whew. That's tricky for kids, right? They keep saying the word least, so then all of our brains go like the alligator thing. You know, your Algebra 2 teacher kept telling you, don't you dare think about alligators anymore. Alligators don't work for algebra. So whenever dyslexic teacher and all, whenever I see the word the phrase at least, my brain automatically flips it to 3 or greater, because I get tricked. All right, number 10. I love this question. I love it because it's so easy, but it freaks kids out. So this equation, polynomial, has roots of these. And they want to know, what does that mean for its factors? This is actually a really easy question if you have the vocabulary down. Think about what happens when you have a factorization of a polynomial, guys. Your factor then gets solved, and that's how you find the roots. So, like, for instance, a root of -1 probably had a factor of x plus 1. Oh, we're done. Ooh, see it? So, like, this was a factor of x plus 3, and this was a factor of x minus 5, which the other ones weren't listed there. So, all right. Man, we're on a roll. Look at us go. Oh, and goodness, look at that. Ooh, this problem. Okay, this one gives a lot of kids a lot of stress because they're like, Ooh, exponent rules. I don't remember them. And then on top of that, they have radicals. So I'm wondering if you guys can throw out some exponent properties for me. First of all, I'm looking at the x's for now. When I have x to the second, over x to the 1/3. Anyone have any thoughts about properties of what we can do with that? Because that's not simplified clearly. And my rule followers are going to tell me we subtract the exponents. That's true. You feel like subtracting fractions right now? Yeah, me neither. My manipulators, it's kind of a bad word for you, but my children who approach these through manipulation, when you have a negative exponent, doesn't that mean you just move it to the other side of the fraction bar? So that x to the -2, I'm just going to throw it down to the denominator. And I'm going to leave it there with the x to the 1/3 for a moment. Just leave it. We'll come back to that idea. And then same thing with that weird y to the -1. I'm going to flip him up to the top of the fraction bar. So it's y to the first, and then I'm going to leave it next to the y to the 1/2. Guys, I think I'm done. I just have to do a little adding, that's all. So exponent properties say when you are next to each other like this. Actually, you know what? I lied. I don't even have to add anything. What happens when you have a rational exponent like that? Like y or x to the 1/2 power, what does that really mean? Square root. So this says y to the square times the square root of y. So then what does the 1/3 power mean? Cube root. So that's x squared times the cube root of x. Please tell me that's an answer. Yeah, I see it. Right there. Well, that was fun. You got that face. Is it the exponent rules or is it the radicals? The whole thing. She's feeling all Debbie Downer now. Do you remember that exponent rule? Okay. Do you now remember that you can change exponent fractions to radicals? Okay, that's all that matters. Now that you remember it. All right, number 12. We have a function, which is a quadratic, by the way, but it's in factored form, which is my favorite form. Which of the following intervals contains the x-coordinate of the graph? Now, I'm a bad person for like interpreting a graph without actually seeing the graph. So even though I can't use my graphing calculator, I have enough knowledge of stuff to figure out what this kind of sort of looks like. Guys, this is a parabola with roots or solutions located at -3 and -1, right? If you solve both of these. So I don't really know exactly what this looks like, but it's got a positive coefficient. So it looks something like that. I know, it's a beautiful graph. You can be jealous of it. It's a terrible graph. The vertex is what they're asking me about. The x-coordinate of the vertex. Well, I know exactly where the x-coordinate is. What's in the middle of -3 and -1? -2. I don't care about the y-coordinate. They don't even ask me about it. But they do ask me the question in a very weird way. Is -2 between which of these intervals? B, right? Between -3 and 1? Yeah. So that wasn't really too difficult of a question once we kind of filtered through all the concepts there. Oh boy. I know what happened when a bunch of you saw this question on that test. You were looking at it and you're going, I'm going to factor and cancel stuff because everyone loves a good factoring and canceling question. And then you went to go factor and you went, oh, sugar snap. That doesn't factor. So then you went, oh boy, how do I divide polynomials? And I go, two choices, long division or synthetic division. So then where'd you go? Synthetic division, because no one likes long division except for you weird people. So who remembers what we put in place of that weird little half box for synthetic division? If I'm dividing by this, yes, I put the solution to that divisor goes in the box. And then I'm going to line up my coefficients in standard form order. So we have a 1, we have a -2, and I crossed off that sign. What is it? A -5. Leave a little space, draw a line. Remember how to rock and roll through synthetic division? You bring down the first coefficient. And then it's a series of multiply, add, multiply, add, multiply, add. Here we go. 1 times 3 is 3. And I think I'm actually done, but let's keep going anyways. 1 times 3 is 3 again. Add these up, you get -2. What is this last number you get in synthetic division? That is the remainder. So I'm looking for an expression with coefficients 1 and 1 and a remainder of -2. Ladies and gentlemen, it's B. I love synthetic division. Actually, I like long division too, but not enough to do it on a test. All right, number 14. Now, guys, notice we are very close to the end of a section. So if we hit a question where it gives you a couple of moments of like, man, that's a thinker, it's okay. This is where they show up, okay? So like that synthetic division one, if you're like, I don't think I would have got that so fast. Don't panic. We're at the end, okay? A shipping service restricts the dimensions of boxes it will ship for a certain type of service. The restriction states that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box and the height cannot exceed 130 inches. The perimeter of the base is determined using the width and length of the box. The box has a height of 60 inches, and its length is 2.5 times the width. This is a lot of math. I think I need a shape. We're all in trouble, because now I have to draw a rectangular prism. All right, here we go. I'll be honest, if I was doing this for reals, I didn't draw anything. Because you know what's going to happen now. It's going to look really bad. Fun fact, my kindergarten son is currently working with rectangular prisms. And he often wants me to draw them for him. Yeah, that wasn't too bad. Yeah? Yeah, squint. It's okay. Oh my gosh, my contacts just shifted and now I can't see any of you. Hold on. I had to concentrate so hard on drawing, I like moved my eyeballs. Okay. Oh my gosh. Seriously, I can't see. Okay. Anywho, they told me some information here, guys. Didn't they say the height of it was 60? Cool. And then the length, which it doesn't really matter who's your length and who's your width at this point, guys, but the length is 2.5 times the width. And then it keeps on saying that the width is, they're going to call width x. So I'm going to call this the width x. The length would be 2.5 times him. Notice how I went ahead and did my thing, because we're about to talk about perimeter. Okay. Right here, the sum of the perimeter of the base and the height cannot exceed 130 inches. We need to set that up. So what would be an expression for the perimeter of this base? Remember, it's all the sides added together. But to simplify it a little bit, just call it like 2 of these plus 2 of these. So that would be plus 5x. Keep reading. Sum of the perimeter is base of box and the height. What was the height? 60. And I ran out of room like an idiot. Should have wrote that over. Ugh. Cannot exceed, all right, friends with my inequalities, if I cannot exceed 130, what inequality is that? Less than or equal to. No, you're in business because they didn't really tell you much of anything here. That's all less than or equal to. 130. Keep going, guys. Mine doesn't look like this. That's okay. We'll talk about it in a minute. Keep solving. So we have, what, 7x here? I'm going to subtract the 30 over. Oh, this is like your lucky day, guys. Divide by 7. X has to be less than or equal to 10. But notice they have these weird sandwich inequalities over here. Because if you think about this logistically, you can't have a negative width of a box. So they said, well, you can't go beyond 0 either. So A is your answer. That was a hoot. Can't wait to do more of those. That was the geometry problem they snuck in there on that test. You see it? And I think that might be, unless I forgot, that might be the only geometry question on that section. There's one on the gridded response, but on that section I think we're good. Okay. Did I skip a question? No. Oh, there's one more. Keep going, Abruzzo. 15. The expression 1/3 x squared minus 2 can be rewritten as that, where k is a positive constant. What is the value of k? Now, my friends of Algebra 2 and beyond, you're looking at this going, I got this. It's a factoring question. I am amazing at factoring. And I don't doubt that you do have this, but this is actually a lot harder than it looks at first. So when they have a 1/3 in front of your factorization, like this, that indicates they factored out a 1/3. So what we need to do first is take out the 1/3 from the expression as a whole entity. So this guy here, if you factor out a 1/3, remember factoring out is synonymous with dividing. So you have x squared minus, what would happen to a 2 if you factored out a 1/3? Remember, dividing fractions means to do what? Yes, flip it, it's a 6. Good. All right, guys, we're not there yet because they're still trying to trick me. Because right now you're all excited about saying B is the answer and B is not the answer. Now they want you to take this quadratic and they want you to use what we know as the difference of two squares factoring pattern. They want you to split it up into that good twin, evil twin factoring. So I'm going to do that. The way the pattern works is you square root each term. So the square root of 6 is nothing pretty. We're just going to call it the square root of 6. All right, guys, I think we're home free. What is the value of k if I go back and look at their weird thing? It's the square root of 6. Oh, boy. Now, as a test taker, I'm just going to give you a little insight into the laziness that is my brain. When I look at my answer choices, there's these two and there's these two, right? Square root of 6 and 6 and square root of 2 and 2. So obviously they wanted me to either decide whether I had to square root something or not. That's for later to decide. For me, I'm looking at this question going, oh, well, here's the original factorization. I have to factor out a 1/3, which means the 2 is going to change. So clearly 2 and square root of 2, like, that's not going to work. So already I was narrowed down to the 6's. And then the deeper I thought about it, I went, oh, yeah, I'm going to have to square root it. So I technically could have done that question without picking up my pencil. But I am a math teacher. So let's see. I should be able to, right? So we already did the gridded response, which means at this point, we should have had that whole test done in our 25 minutes. But remember, you don't have to be perfect on this test unless you are literally looking for a perfect score, guys. We haven't had much time to talk about this in all the tutoring sessions, but does anyone have their eye on like what they think is a good score and how to get it? And I can't really tell you like exactly, like some kids will want to know how many questions do I have to get right in order to get this score. Every score is normed differently, but I can give you an estimate. And the internet can give you an estimate too. If you're looking for something in particular, you don't want to shout it out. For an average score, which is about an 1100, I always tell my kids to get like a D, like a middle to upper D. That's not too bad. That's average. So on a standardized test, the scale has been shifted because like it's everyone's competing against each other and it's like high stakes, right? So if you got like a B on this test, I mean, that's a great score. Like we're talking, you're almost to the 1500s at that point. Yeah, that's big. That's a big score. You're in the 1400s. So it's not like I need to ace this test. That's not your go-to attitude. Because if you start going into this test going, I need to get an A on it, every question that you think you got wrong starts bogging you down and you get all in your head. And I think we've all had that moment on a test where we're in our head and we're not really feeling good. Okay? So the test will end at 25 minutes. And when you decide that you are done with that test, you look up at the clock and you go, oh, cool, I have 3 minutes left. What do you do with those 3 minutes? You go back to that one question that you never got a chance to finish or check, or the one that you guessed on, and you try it again. At no point do you waste time on this test. I don't care how confident you feel. You go back and check it. So then your proctor will read some instructions. They'll say, now it's a calculator part. Get out your calculators. So get out your calculators. If you don't have your own calculator, your room will have like a set of 15 to 20 calculators in it. But guys, you have 25 kids in your room. So if every single person needs a calculator, we're in trouble. Hopefully we don't have that situation. So I always tell my kids, if you're one of those kids who needs one, get to your room early and just tell the proctor, I will need a calculator ahead of time so they know that you get one. Okay? So, calculator test. Same formula sheet as before. Calculator section is much longer, both in time and in length. There's more questions here because the non-calculator portion of the test is there to really weed out our top scores from the kind of top scores. So like the kids that's getting a 1530 versus the kid who got a 1490. Like those are the questions that kind of peel those away from each other. I'm not saying, you know, if you just want a 1200, I'm not saying blow that other section. Like, you still need to do and get points on it. Oh, speaking of which, no one's asked me this yet. What do you guys feel like? The harder questions, you think they're worth more points? No, they really aren't. Sometimes one of those harder questions will be thrown out, but you won't know that until like months after the test is given. So every question's worth the same. So don't feel like you should spend 20 minutes on a question because you're sure it's like totally worth it. The answer is no, it's definitely not worth it. All right, moving on. We have 55 minutes to get these 38 questions answered. And are we going to start at number 1? No, we aren't. What are we going to do? We're going to tap. Get over there. Tell all your friends they're supposed to start on the gridded response. I don't think kids know this. I mean, my kids do because I yell at them all the time about it, but like I don't think other kids are listening to their teachers. I'm a little concerned. So you're going to start on gridded response because in the case that you run out of time, at least you can make a guess on the multiple choice ones. It is the first question in the gridded response, so it shouldn't be too bad. Let's hang on. Oops. Look. So, in 1854, during a California gold rush, each ounce of gold was worth $20. The largest known mass of gold was worth 62,400. What was the weight in pounds? So we do have to do a little converting, and it is gridded response, so the chance of you guessing this is very slim. Don't bother. So let's start with a proportion. And remember, it's a calculator test, so you should be typing in your calculator. So $20 per ounce. You could start converting it if you want, but I'm not going to. And then 62,400 is some mystery number of ounces. Can you guys find that for me? What is 62,400 divided by 20? But this is ounces, right? So then what am I going to do? One more step to convert it back to pounds. Divide by 16. Thank you. Did you guys get 3120, by the way, before you divided by 16? I hope, maybe. Did you get 195 pounds? Because that's the right answer. Okay, cool. So you bubble in 195. Make sure you fill in the boxes at the top of the grid and also the bubbles underneath it. And don't get cute and put extra weird zeros before it. Just put them in the first 3 boxes and walk away. Well, bubble and then walk away. All right, number 32. Line T is on the XY coordinate plane. What is slope? Really? We got this. What's the most common mistake in slope? Flipping the formula, yep. But, so what is the definition of slope then? Because this is not on our formula sheet. You have to know this one. Yep, it's rise over run. So the official formula is y2 minus y1 over x2 minus x1. But because we have a graph, I might I might try to count it. But, oh, look what they did. Guys, they gave you fractions. But it's okay, because guess what else you have? A calculator. All right, here we go. Pick your 2 favorite points. Guys, is there any... Oh, man, they all have fractions. Do you guys mind if I just choose these 2 points? Anyone know why I went with those 2? Yeah, I mean, they're a little smaller. Potato again. I don't really care anymore. All right, here we go. y2 minus y1. I don't care who y2 is, just stay in the same order. I'm going to go here with y2. So 3/5 minus -2 over x2, 9, minus x, oh boy. All right, here we go. Calculate away, my child. We are on the calculator section, right? I keep saying that. Okay, cool. If you're doing this on your calculator in one step, which I highly encourage, because think of like, I don't run, so I'm not even going to pretend like I do. But if I ran, and I ran a really long race, I would think conserving your energy appropriately would be very smart. Think of it that way. I know you guys can subtract fractions, but you're trying to conserve energy, so just type away. Make sure you use parentheses though. And this does come out to a fraction, so please hit math or enter because we're going to want to bubble it in as a fraction. Although it does say on SAT's website that they accept 2/5, 0.4, 0.40, 0.400, 4/10, and 8/20. Yeah, I don't know why they accept all those, but they did. Did you get 2/5 though? Cool. All right, moving on. The score on a trivia game. is obtained by subtracting the number of incorrect answers from twice the number of correct answers. A player answered 40 questions and obtained a score of 50. How many questions did the player answer correctly? Now, you are welcome to try to guess and check your way to the right answer. I think that's an ineffective use of your time, though. Everyone always rolls their eyes at their algebra teachers when they say to set up algebra to solve this. This is a good moment why you want to set up algebra. Let's set up algebra. I want to know how many questions did the player answer correctly. So we have correct and incorrect answers, right? And this is the step where, like, again, kids roll their eyes at me. They're like, I don't want to do this step. Do it anyways. What do you want X to represent? The correct or the incorrect? I don't care. Correct, okay. So Y would be the incorrect or the wrong ones. Keep reading. A score is found by now careful, subtracting the number of incorrect answers from twice the number of correct answers. So subtract from is one of those backwards subtractions moments. You got to like flip it around in your brain, okay? So twice the correct answers, you're going to subtract from that the incorrect answers. Got it? And at some point in your clues, didn't they give you a score? Where does that say? Oh, a score of 50. Okay, there's one more clue out there, and it's its own equation. It says your player answered 40 questions. So the person either got each question correct or incorrect. So that equation would look like what? X plus Y, all the questions, equals 40. Okay, now keep your eye on the prize. I want to know the number of correct ones. So I would like to solve for X. So I want to make sure we knock out the Y. Guys, it's like your birthday. The Y's already knocked out. Look at that. Look, another system, children. They love a good system on this test, don't they? All right, 3x equals, I need this move. 3x equals 90. So x equals 30. Oops, those equals. We'd bubble in 30. We'd move on. Ooh. Nice little geo question. Point P is the center of a circle. Cool beans. What is the fraction of the area of the circle that's shaded? Thoughts? Now, kids freak out on this one because they're like, wait, area of a circle, according to my neat little formula on the front of my formula sheet, I'm supposed to find the radius squared and multiply it by pi. But they didn't tell me a radius. And I think your math teachers would tell you, no, they didn't, and I don't think you need it. Because how big is a full circle? Yeah, can we just set up a little fraction? 100 divided by 360. It doesn't say how they want the answer set up, so I don't think you have enough boxes to do 100 divided by 360, so can you math enter that for me? 5 over 18, yeah. And that would be what I would bubble in. But it does say, this cracks me up, it does say they will accept 0.277 and 0.288. I don't know why the 0.288. I was a little confused by that, but I was like, whatever. Oh, you know why? Some kids do this problem by plugging in like a generic radius. Like they say, like, my radius is 4. So if they go find area and they use pi, I think something happens. No, that wouldn't happen. I don't know why they would accept 0.288. I don't care. Let's move on. Oh, 35. Oh, look, guys, another system. Oh, we're done, by the way. If you guys got to go, I want to just do this one, and then I'm going to stop for good, okay? 35. It's another system, but this time, guys, this is a super fun system. This is a quadratic system. They want to know the value for x, which means I want to solve for x. Guys, if both of these equal y, that means we can do this. We can substitute. So 4 minus x. Oh, you know what? I lied. Scrap. What kind of test are we on? Calculator. I need to think like a lazy kid. What should I do? Graph it. You have a $150 machine, people. All right. Now, not everyone in the world has one of these calculators. What I was about to do was the algebra way, and it was smart and it was beautiful. But everybody else on the planet who has a graphing calculator is just going to type this into y1 and this into y2, and you're going to get, there's actually 2 places where this line and parabola intersect. ACT will accept either answer. No, SAT will accept either answer. Wrong test. It even says right here, I will accept 0 or 3. So when you guys graph it, just tell me in like a standard viewing window, does it look like the line and the parabola are crossing at x equals 0 and x equals 3? And if you didn't believe me, you could go do the intersection thing on your calculator, right? Second trace. Yeah. All right. Tapping out.